Can you see me? Am I moving around, flailing my arms? Are you there? Are you here? Are we anywhere? Don't worry, hold up. If you're seeing me on your screen and you're wondering what the heck we're doing, why I'm green, just hold up, hold on. We're syncing the servers up across the places everywhere we are located. We're gonna find out, sort it out, and make it happen, Captain, because I know what y'all want to hear, and it's getting ready to drop. Welcome to the show. I'm 3D, and today is another episode of 3D Changes Perspectives, where I want to try to change, obviously, your perspective. Now, today we're going to try to work on something that, maybe you haven't heard of it, maybe you have. It's relative to the new DAG blockchain, SUI. And if you have, again, already heard of it, it's spelled SUI. And if you know at least something about it, hold back. I got some more. Definitely have something different than what you normally read out there. And so now the question really truly is SUI any good? Is it worth diving into? But most importantly, we want to discuss how easy or how difficult it could be to attack SUI. And by answering these questions, whatever perspective you have on SUI DAG, most likely will be different from there on after. And it's, it is what it is. It's how it's supposed to be sometimes, whether it's for the good or for the bad. Does look like YouTube is giving me a bunch of problems. Hopefully that audio doesn't leak in later. Alright, so right now what I'm doing is I am getting set up the chat. So while I do that, why don't I go ahead and thank the organized, one of the most recent Bitcoin Live digital broadcasting DB partnerships. Bitcoin Live DB with the organized is a powerhouse combo, and we are growing. That's a good thing. So thank you, the organized, for partnering with us and helping today's episode. We also have today's sponsor, which I think it's pretty much the only sponsor I've ever had, but it's also the network sponsor. I want to go ahead and thank Shieldfolio for today's episode. And what we have here today, Shieldfolio, in case you don't know, it's like a little black book. It just allows you to write a lot of things in there. Anything from like your passwords to your crypto keys to hash keys to anything secret, even like addresses, information, like a little black book or anything that you'd want to use it for. And the best part of it, I'm sorry, let me catch my breath. The best part of it really is the fact that it's made with stone paper, which, well, it makes it tear resistant, fade resistant, water resistant, all those really neat features. So it's a little black book designed to survive and last through the things you need it for. And if you use the QR today, which you see right there behind me, and if you look down at the bottom, there's going to be one throughout the whole episode that you can scan, go to their website, and grab one of these great books today. Use the code BitcoinLive20 to get 20% off since you watched today's episode. Alright, thank you again. Now let's roll in with the roll-ins and get on with what we're getting on. And you guys saw that, right? Sorry. Okay, I guess the intro might not be working today. It is set to the right spot and everything. Let's try it one more time. So far, every time I hit play, it just disappears. Well, snap. I am glad I got that going. I love that intro. Thank you again, Shieldfolio, for today's episode. and I'm super stoked about the new deorganized partnership with the network Bitcoin Live DB. Okay, now we've gotten through the semantics, we got through the beginnings, we got through the intros, we got through the stuffs. You guys want to know more about SUI? I put on there that it is another DAG, another SBA, another ETH. And I mean this in more than one way. So you guys, I really enjoy the difference because it's not, I guarantee it's not what you're thinking in any way, shape, or form when I say it's another ETH. So let's start off today with some news. If you've heard about this, this is probably news you've actually heard about. And it's right here. It says the SUI network backup after a scheduling bug leads to 2-hour downtime. This is pretty much what a lot of people seem to know of, but not and so again, throughout the episode, you will see QRs pop up. That is where we're at. So if you want to follow along or whatnot, or even say hello, because yes, I do have the chat. Well, I think I had the chat. Let me double check. Oh no, I don't have chat up. Let me double check. Yes, she heart. No, you don't see her. Try it again. And now we got it. All right. If you go to YouTube right now, I'm sorry. If you guys go over to YouTube and find this live stream on Bitcoin Live DB, 3D Change Perspectives, you can actually join in, say hello, and ask questions or comment as we go live. So basically, what everybody has known is that SUI had a 2-hour-ish downtime. So a lot of people are saying Solana much. And well, there's a chance that Solana crashes were not all directly code implication issues, but potentially DAG, proof of stake mechanic issues. And I know this article doesn't explain the main cause of the issue or how it exists, but just take this as like foreshadowing. DAG isn't time released, but time reliant. One of the greatest points of Bitcoin is that nothing is based on in real lifetime factors, only on block cycles, average hashings of the cycles of 256, time to start sync nodes, and duality distance timing. That's the difference of handshake timing for close to you nodes versus far from you nodes. And so now we have that out of the way. Let's really look at SUI right now, because you hear there's downtime. You're probably wondering, is it up and running right now? Yeah, actually it is. It's doing great. So here's all their info. We can see past incidents, and boom, there's an incident right here. There's the one everyone's talking about. Yeah, that is it. We're just going to jump over to their incident page to see if this is the only incident, at least lately or whatever. So of these sets of months, yeah, that is the only incident. I bet we can go. Nope, can't go any further back. We can go forward. July 2024, November 2024. So they've had 2 major incidents. Oh no, 3 major incidents. 4. And the 5. Okay, there we go. These are all similar issues we see on DAGs and we see on proof of stake, and especially DAGs that use proof of stake mechanics. And I think that's a kind of a heavy point, and we'll get kind of into why, I think, and I'll just kind of break the ice. They claim they work on proof of, this is a proof of work chain. Let me get you this QR one more time just to make sure you guys got it. So, as we see, SUI has information tables like what we're just looking at, and sites like this one, for example, which I have in reader mode. But it's all similarities to ETH and the ETH Foundation stuff that was released at the time of like launch, and it's updated over its lifetime span. Like they still right now have ETH similar pages that we're just like looking at like right now. This SUI Blockchain Explorer, there is an ETH Blockchain Explorer explainer, I mean. And just like there is a way you can view ETH downtime and ETH up if it's currently up right now. And I think even some certain different exchanges and systems on ETH, you can even check to see if they are specifically up or down or available, like through your RPC or something like that. Like, there's all sorts of different ways to I don't know, check the same type of stuff. So that's what we mean by it's very similar ETH. We basically have just an explainer of SUI from SUI. This is from SUI explaining SUI to you. And as we have, let me get back on track with my actual notes. So this has kind of become a norm to have these type of pages for all enterprise or publicly private formed chain foundations in almost all proof of work style or proof of stake style chains. And I say it that way, because I want to make sure, like, I was about to mess it up and go, but proof of stake style chains, not specifically just proof of stake chains. So just from that, yes, SUI is a DAC chain, and with almost all DACs that have proof of stake design mechanics for either consensus or security, they seem to suffer from the same flaw. The problem is that DAC and proof of stake are not good at security when they're together. They both seem to cause vulnerabilities when they're together in the network. So this is why ETH created its own programming language initially. It was, at the time, they claimed to deter attackers because they would first need to learn the programming language to attack. But then what actually happened was the hackers and attackers became the most fluent in the programming language, and even going to some major pages that tons of people use to create all their ETH drops and stuff and ETH contracts, they actually claim to be ex-ETH hackers and attackers because they're the best in the business and they're not lying. But that's kind of my point here, is you're most likely going to have that exact same issue with SUI. SUI has their own programming language. SUI, you can see it's some of the best people, like, in tech, security, and databasing. These are like the best. These are like not just random nobodies. These are the top of the top people. Evan Chung, former head of research and development at Novi, technical director of Meta. Early was working 10 years at Apple before that. I can't actually say the guy's actual name. AA is what I'm going to go by. Former head of product development at Nova and Meta. Previously worked at VMware, Oracle, Pure Nova, SBC, and JP Morgan. Sam Blackshear, CTO, former chief engineer at Novi with expertise with the Move programming language. George Denise is chief scientist, former researcher at Novi and Meta, previously worked at Chainspace and Microsoft. And then Constantinos is formerly leading cryptographer at Novi, previously worked at R3, Embryo, Safe Market, and NuCrypt. God damn. These are like kings of their what they do. If you was to say, who could you go to does this better? The only people I know who, for example, does the cryptography better is in jail. Sal is in jail. He ain't coming out to... Everybody else is already locked up. Like, these are the best of the best that you could get your hands on. And these people are the ones leading this. So, in the realms of fundraising, they raised a lot of funds. FTX, Ventures, Electric Capital. So you'll see a bunch of people are involved with this. And some of these, if you're in the crypto space regularly, you'll say, hey, problem. You see a lot of problems on this page right here. But if you're an influencer in the crypto space, you're probably happy as heck. I mean, to be honest, I will give you like what my actual thought is with SUI at the end. I just want to first give you guys all the full whatnot I can. So I do have, I think, notes on this one. And we're done with the notes. We're done with the notes on this one. Let's go to the next one because it's more of like a fluff piece or whatever. Again, I have it on reader mode. SUI versus Solana, comparing adoption, scalability, and more. So that's kind of the key point here, is they're putting it right alongside with Solana. And if you remember, Solana was an ETH killer, so SUI is an ETH killer. But actually, it's a competitor with both ETH and Solana. It's actually a competitor of quite a few different chains, because quite a few chains that all do basically the same thing. And we want to look at this right here, so we can see SUI was funded in 2021 by former Novi financial and labor project developers. Solana was made by XQuam engineers. Main lot for SUI was in 2023. Other one was in 2020. So for this point, I'm just going to really stick to SUI. SUI is using delegated proof of stake, object-based models, and move programming language. So in case you don't know, DPoS, a lot of people call that a proof of work. It's not. It's not proof of work. It's actually, I like to call it controlled proof of stake. And proof of stake already is 100% controlled. So what you're actually doing is you're giving up control in one way, but keeping it in another, is all that really means. And it's going to be through, in this case, like validator limits and other little things. 297,000 TPS parallel processing, the non-consensus transactions. Keep in mind, that's non-consensus transactions. The fact that you can have non-consensus transactions is a problem in the first place. But yeah. But sorry, my dad's cat knocked my headset out of its little plug-in thing. But 200, what you're getting out of that is almost 300,000 DPS. And if you're considering it right next to Solana, that's very nice, comparable, right? But transaction finality, very short, 390 milliseconds. That's not a lot of time to really react to be able to say, no, we don't need something. And up to 12 seconds on the other one. So SUI is also object-based orientation, which, to be dead honest, makes perfect sense. This is why, like, I personally use object-based coding languages. OP is the way for me, as they say. So it just allows you to visualize what you're making easy. So it's normally easier for the developers to build stuff, which then you have the program language dissect what that really means into controllable output. No matter what you input, you can have basically a guaranteed controllable output in some form, even if the input is extremely dynamic to any possible output, which is what they did on Ethereum. It's exactly why they did what they did with Ethereum with their programming language. They designed the output to be very super specific, which later bit them in the butt. The programming language here is Move, which is based on Rust, so it's just like Rust repurposed in a new manner. And from everything I looked on, that's really designed to make integration slightly easier for general developers. Like, you don't need high-end developers to really work with this. You just need someone to sit down and take a lot of time to learn this, like in early days of ETH. And that is what it is. Now, validators. You see the number of validators? 108. That's terrible. I don't think if you have proof of stake validators, it's got to be anybody and everybody who wants to be a validator can be a validator. You stake so much, boom, you're a validator. So having limits on validators is a controlling point for any and all chains. So decentralization, it says highly centralized due to high staking requirements. That's for SUI chain. They put on here SUI chain actually is extremely centralized in the ability to. I hate to be honest, it's not even. I don't think that's even for validator. I believe that was for full interaction, or I don't remember. It's terrible. Staking rewards 3.3% with slashing and enabled. Take it or leave it how you want that to sound. Development entity, Miston Labs. See, both of these have a development entity. That's probably a terrible thing. I always think that's a terrible thing when it's started by an entity like this, and not just like a group or collection or sole individuals even. But that's up to everybody to defer differently. Funding, you'll see funding is from similar places. Ecosystem size, way smaller here because it's much newer and it's quite high in value, which means there's a lot of big money here. So, focused on Asian markets and partnerships with Alibaba Cloud and NHN. And ETH did the exact same thing with AWS. Hardware for SUI is they have a handheld gaming device, I guess, or they're supposed to have one. So that's their thing. Challenges is the move language is still untested, and the focus is in 1.8 regional. Target market again is really game based. It's high. That's why they want non-chain transactions. They want transactions that don't have to go on chain, so that they don't have to go through consensus. Because in gaming, there's a lot of little actions that you don't want consensus in. Maybe you want to put them on chain for like a save state or something, but you don't want them all to just like cost you money. That makes sense now, right? Okay. Now we have a reason to explain one of the problematic points earlier. Non-consensus transactions. And the problem I do have here is the TPS for non-consensus transactions is quite deliciously good. So now we don't actually have a clue what the real TPS is for consensus transactions. We don't have a clue what that is. We don't really know. I'm going to assume the transaction speed is the same, but the TPS has got to be way different, or else it'd be listed. So token SUI has got a 10 billion max supply, and it says 50% community reserves. I don't even know what that really means. Community reserves is a vague term. The last time I saw something like that on a crypto thing, it ended up just being the owners. Who knows? And that's kind of the thing here. There's a lot of trust. Something you're not supposed to have in crypto, something I always say, don't trust. There's going to be a lot of trust in some of the stuff, but same thing with the blockchain they're comparing it to. And ETH, even. Same thing. Got to have a lot of trust in that now. Because it's no longer proof of work. And then they have a place where you can buy. And so that's the other thing, is these are purchase only. So buy, enter. You have to pay to enter. And that's also known as pay to win. So here's some more information on them. I'm going to go ahead and give you guys that QR again, in case you want to come back here and do more informational reading. But I am looking for another section. So let me see if I can find it real fast, because I'm sure I can. No, I'm not seeing. Oh, there it is. Look at that. So they're comparing the tokenomics directly with Solana, the fees and everything, because it makes them look. It makes SUI look way better. And Solana is probably like the closest one with high TPS to compare it to anyway. So I think we look at it like they're comparing it with TPS matters. Yeah, sure. I mean, I know faster chains, but they don't have as much TPS anyway. So, okay. And it shows you the allocation, so you can get an idea of all that. But I think this right here shows you some control point. The team and the foundation together is 40%. That's almost half. Okay? If anybody from the team and the foundation was involved in the funding cell to equal a quarter of the funding cell or more, there's a chance that they actually, some set of individuals that correlate between those three sections could have majority say on chain. If there's any number of people correlated between seed cell, foundation. Again, we can say without a doubt, by math, there is potential for a group of peoples that have majority say on chain. There's any number of peoples that correlate between seed cell, funding cell, and validators. They have majority say on chain. If anybody out of any 4 of the 20 or more percentile sections have any correlation with themselves in any manner, and they all would have majority say. Those 4 sections, 20, 20, 25, 20, but also that's 0.2, 0.2, 0.4, so, and 0.6. So 40, 60, 85, no, and then 0.486, so 86 point something percent is potential just there. You add in validator, 8.2. Well, you're over 90, you're almost all the way there. Nothing else really matters. And so what it comes down to is, how are you getting your soul? This is the initial supply distributed, right? So your soul is after the initial supply? Or is your soul coming from one of these? No clue. There's probably ways to tell eventually, but I just want to point that out. Other ones like this I've seen in the past, the initial allocation will still have a section unused, or a section reserved for actually something. This has no reservations. This has no anything. And the public auction cell was only 2%, and the strategic cell was 3%. You add those together, you have less than 6% of the entire allocation of 500 million. And it's like, okay, but they have a huge amount. It'll take some time to get there. And that's the other part. So until they get to like 80% distributed coins of total possible supply, they have majority say. And there's a chance that if any of them have enough, that there you could say that one individual has a majority say on chain now, that there is a potential that that one individual could keep buying enough or whatever, or just already have enough to have majority say at 100% distribution. That's my fear here. And you're going, but this is just the 500 million initial supply. And that's my point. You got so much here that on tops and tips where it's like high in value, these individuals could sell enough to buy back plus every div. And if they have enough money and they're staking enough and they're not doing as much on chain, they'll potentially earning funds in the process. So what I mean by that is, like, that's how these systems are supposed to be designed. If you have a lot of stake in a system to help ensure it, you have the chance of making a lot of money. And that really is one of my points. The fact that this system is designed for key individuals to make a lot of money means they're going to want to make sure this works. I am dead serious. They're going to want to make sure this works. So let's keep going, though. I don't want to stick and harp on that. We'll get on that some other time later. I actually, like always, got the real deal data points for you guys. Here is the SUI GitHub, which did lead us to who actually went behind SUI, which we already read who it was, Smithson Labs. We'll get to them too. Here's SUI. Here's their architecture. And you can see the point of failure right there. Client service goes to authority aggregator. Well, if this was Bitcoin, the client service is the authority aggregator. Boom. Everything goes back to client, authority client after that. So, boom. There's your point of failure. In case you were wondering, that's how you get in. You want to break this chain, you want to do anything to this chain, boom. The fact that they have non-consenting transactions means that there's another way in. I mean, like, just hearing these words tells me there's some form of loophole somewhere. Take advantage of that, because that is not a bug you can fix because you're using it directly as features in the chain natively. You're screwed. How easy is it to do that? Because that's one of the points I wanted to point out. How sophisticated of an attack does it have to be? And we will actually, I broke it down because someone broke down at least one attack that had happened. We already looked at 2 different points where they went down because of it. One when they actually did the attack, and another one later happened because of a fix they implemented that never actually fixed it, and it ended up actually just naturally messing up again in the exact same issue. And there was public information about that where they were talking about how a bunch of people had to help them, whatever. It was people running their own nodes had to basically go in there and do manual updates or something, and that is what they meant by they helped. And okay, cool. So there's a way to update your own node, and in times of needs, they can produce very quick fixes. Well, that's why they have funds to pay people, I guess. Well, they did pay people. And that's the point important. Or they let people buy funds, is what I really should. Anyways, here is the Mist in the Labs repos. So I'm just going to read some of these titles. Wallet block list. Stewie, next generation smart contract platform, blah blah blah. Stewie NS contract. It looks like sinus to me. Walrus site. Walrus stock. Stewie the Rust. That's probably to use this their actual programming language in Rust environment. Stewie Genesis. Walrus Stalker testbed. Perfectly great that they actually have something like that. Anybody to be able to copy and use. Very useful. Move Nursery. And it's becoming more common anyways. Going. Move Book. Super common. Keep going. Deep Book for volume version 3. Kind of confusing. I mean, anyways, that's my point here. Some of the stuff seems perfectly normal. Some of the stuff seems very freaking weird and fishy, confusing. But you know, it can get worse. It could be worse. And I think out of everything we've seen, at least the code they have is tip-top shop. It really is. I can't complain about the code I see. It does exactly what it says it's going to do. There might be more stuff going on in some of these, but to be honest, I really doubt it. It just looks like there could be in some of these codes. Like in the wallet block list, there is stuff in here that it could potentially be used if you could have like wallet controlling a wallet. You could actually have a wallet control another wallet's blacklist, and then have a technical virus in the chain that would just basically like turn everybody's block list to block everything that's actively not a part of the scam, and just allow the scam to go through on chain for a while. But to be honest, that right there would be such a highly sophisticated attack where you would have to basically build a self-replicating virus that is doing one specific thing and then dying, but before it dies, it actually implements another version of itself somewhere else to redo it somewhere else, so that way it's not the same data package that it's reviewing in order to do, like, this would be extremely sophisticated, and you'd have to drop it down to a package of about, I don't know, like 18 kilobytes or less is like probably the best bet. But to be honest, I mean, we're talking with a blockchain that you have at least 1 megabyte. So I don't know, 800 kilobytes. Could you handle that? Probably. Actually, that's way more easier than you realize in anything that's Rust based. But in their custom programming language, I'm not even entirely too sure how you could do that. It might not be possible to do it in their programming language within that limitation, which in all the stuff that I'm doing, I'm looking at most likely you cannot even do the attack I'm talking about in their programming language in a single block that I'm aware of on the Sui blockchain. A single block is all I'm talking about. Okay. So make sure you guys have the QR. Here is Theory Foundation's GitHub, which turned out end up being the way to integrate into SUI, which really awesome to see a dedicated thing for that. Really good. I mean, this is one of the better ones I've ever seen. Not even a lie. Honestly, the people, like I said, people behind this blockchain, they actually know what they're doing. And it shows in some of the stuff like this. I mean, we're just going through the same document. We haven't changed. This is the same README. There's another reason why there's so much here. And we'll get into that later. But I just want to show you what they have to offer. Because I've always said code can sell itself. If you got good code, it will show. And they have good code. Awesome SUI, track stash. This is actually a way to stash your tracking data into zero proofs or zero ZK snark proofs, zero knowledge proofs. That way you can have a little more, anonymous stuff in different manners, like purchasing and buying things, like NFTs and such. We'll get into more of what you could be doing with there at that point later on. I just wanted to point out that, like I did before, here's the code if you really want to know. They even have a security audit code, which stuff like that is a bit weird and strange. Maybe that's what they want people to use to do the security audit, or maybe that's how they do their security audit. And if that's the case, it makes perfect sense. It's just, some stuff is very confusing, while for other things, we got to really look into it to figure out what's actually going on, and that's perfectly fine. I just wanted to give you the data. So here is the Mr. Labs website. I think it's by this point it's kind of traditional to show you their website. The more technical the website, I normally say the more marketing they put into, the more they paid into. So, and I've also always said, and I will say again, don't blindly trust the maker's website to find data elsewhere that isn't related or correlated to the company, project, site, controller, foundation, etc., etc., etc. But we're also going to look at what they have, because it shows us what they have, or what they're claiming to have, or whatever it is, blah blah blah. Words. So here's their about page. I think this is one of the first times I've done one of these dives where I didn't really have to dive into each individual entity involved, because they're quite well known by quite a few nerds and people in the security space, at least. So when you go and look at them, the company, it kind of makes some sense why they look and doing everything they're doing. But I also want to point out the amount of class in everything you're seeing. Look at the glasses on the table. High-end tables. Kinda not basic. They're something you would use in a convention or something like that, but a high-end one. You're selling tables and things like that, food, eatery things. So this is probably a higher-end convention hall. Look at the guy's outfit. Normally, the more outrageous someone's dressed, the more class they trying to appear to have or do have. Either or, it's the same difference. Look at the correlation of class in here. And when it comes to stuff like this, a lot of people, they go, what does that matter? It shows they got big money involved. You don't put on high class stuff like this, or people who are going to give you $5, people who are going to give you $20, people who are going to give you $20,000. You put shows on like this, people who are going to give you hundreds of thousands, millions of dollars. You put on that extra look, show, everything for them, because they have a lot more for you. And this is a common business practice. So that's why we're looking at it like this, because it's a common business practice. So I'm looking at these pictures as business. This is all marketing. Picture was taken for marketing. This picture was taken for marketing. This picture was taken for marketing. And some of these might even be set up like this could be a set up image. This could be all their team right in this image. And it could have been done before or after any convention show or anything. because it would look good on them, especially if they were running the show, convention, blah, 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 blah. It doesn't matter. It just makes it look always better on them because they can ensure everybody in the image looks on point, spec on. For example, two different people have traditional watches on. One person has what looks like an iWatch or an iPhone watch. I don't know what they're actually called. And you'll notice the ones that have the traditional watches, maybe one could be potentially a Samsung watch, but I seriously doubt it. Perfectly clear in view. The one in the background, person who's the iPhone watch, isn't. You can't see it. It's fuzzed. They don't want to pay that extra fee. You could say, well, that's not true, but hint. All the other places that pay Apple money have Apple products clearly in view because it would look better on you. It's still in view. See the Apple products? Still in view. But you can't tell that's not actually an Apple logo. That could be a pear. But it's still in view. Same thing over here. Another one I can see the Apple logo in the glass. This is all marketing. And that's how we're looking at it. So here are the founders. Here are all the people that gave the money and want to be involved and all that. Okay. I gotta at least give you guys this info because I gotta look at this. Here is what protocols and platforms they claim, Mission Labs, to have built. Not community built, have built. And some of this is in fact in their Git. And foundation Git. Very confusing. Might mean, in correlation, they own the foundation. Or the foundation owns them. Either way, it doesn't make any difference. They're in bed with each other. Obviously. Like all the others. The Sui blockchain itself, the layer 1, they claim they ain't made. Okay? Move programming language. They claim they made it. Walrus. They claim they made it. DeepBook. They claim they made it. Inoki. They claim they made it. Decoisk. They claim they made it. And you're probably thinking, so what? What if they did make it? They did make it. I want you to be completely aware. They made all these products. Before I did this dive, the only thing I knew is I've heard of Walrus as the decentralized solution to IPFS. It's centralized. It might be on a decentralized network, meaning that it's distributed and decentralized. And I know that sounds very confusing, but it means that it's been distributed into a manner that the users chose to obtain access to the distribution. And if one person has 1,000 distributions of the same, like basically if I have like 20 nodes, it makes no real difference to if I had one node, because my stake overall could technically be the same. And that's how basically that right there, what I just explained, is how almost all proof of stake chains claim to be decentralized. For example, like with Bitcoin, if I have 20 Bitcoin miners, it does not actually make any difference than if I had one Bitcoin miner. My chances of winning the lottery is still 1 in 4 years. Plain and simple. Could I get it 16 times in a row? Yes, and that's been done before, especially on Bitcoin. I could even get 6 in a row, which has been done on Bitcoin multiple times, especially by OpenSea. Not OpenSea, Coinbase. But it's different because the chances are exactly the same. Doesn't matter how many wallets you have, doesn't matter how many miners you have, doesn't matter how much. If you still only have 1% of the mining pool and you have 1% of the total miners, you still have 1%. You have 0.5% of one and 0.5% of the other, you have 0.5%. It takes a combination of the two averaged to give you a percentage. So, proof of stake is a little bit different. And I want to point that out. That's going to be my major point throughout this whole thing. Is I've read tons of articles and stuff that said it was working with a proof of work protocol or a proof of work chain setup, and It's DPoS. I went through and changed all of my notes too multiple different times because it took me a long time to really figure out what it actually was. Because everything I looked into, I see proof of stake. I don't even really see DPoS. And everything I was reading was saying proof of work. And it wasn't until like, well, maybe 3-4 days ago, I actually found proof of them saying it's DPoS. And it's not even really proof of them, it's just a paid article that says it's proof DPoS. That's the closest I could get to what it might actually be. We're going to keep going. So here is Miston Labs. Miston Labs is their own company. That is common or average, I guess, nowadays. You can see everything they've been doing. Here's all the information, the early stage fundraisers, the publicly allowed to view information is on here at least. And so keep in mind, I mean, the value, the amount of money they keep raising seems to keep going up. Some comparisons, I can't open up the rest until, like, hey, blah, blah, blah. We're just looking at this for free. So thank you guys for letting me view at least this information for free. Whoever this company is. Oh, yeah, PitchBook. This is normally we send people you want them to pitch, here we get to stay, and decide if your company's any good. So we see there's a lot of there's 53 investors. I can't remember. Nope. Won't let me do it. It let me do it once, I think. That was it. Oopsies. Should have saved it as a PDF. I normally do. Anyways, let's go back to where we are. We're right back where we're at. So Miston Labs investments and accusations. They've had 25 total. Here's the last 5, or at least 5. I don't know if it's the last 5. Very yeah. Games. That's what they're focused on. And it shows. Okay. There we go. So who are Miston Labs competitors? Near, Avalabs, and Solana. They didn't put on their ETH and a bunch of other potential players that of mine. But Near, I don't think I've actually met anybody who could fight Near out. Near is extremely good for a reason. So just seeing that on there did kind of give me a chuckle, because in my personal opinion, Near is on its own level of everything. They basically do their own thing. Alright. I want to go ahead and let's go here. This is Crypto Slate. This is in reader mode, but it's going to allow us to basically get a little bit more of the background. So, Miston Labs is a Web3 infrastructure company headquartered in Palo Alto. Founded by former Meta employees, the company is primarily known for the Sui blockchain, and they call it in here Sui blockchain platform. And I want that to be explicitly clear. If this is a paid piece and that was approved, that's bad. That shows that Sui blockchain is controlled in one way, shape, or another platform. If that's just misspeak on the writer, you're gonna have to find out. Miston Labs focused on creating scalable blockchain infrastructure solutions aimed at mass adoption of decentralized technologies. So, ETH used to make similar claims. Similar. I don't really want to go through all this stuff. I think this consensus mechanism was the real thing we wanted to get to. Again, it employs proof of stake consensus. That's incorporating Narwhal and Bullshark protocols into their consensus. So parallel transaction processing, immediate transaction finality, and high throughput capabilities with enhanced networks. Now, I will point out, I've talked about it many times, not on this show, but elsewhere, how the faster a transaction can finalize is bad. That if you can get any amount of attack through your validator, it's almost instantly in there. Like, we'll actually show you link to a video you can listen to later in your own time about how to actually abuse concreting, what it's called in blockchain, which is when you have a near instant or sub-second transaction finalization, and you can completely finalize a block and go to the next transaction and be able to transact that next UTO within that same second. This creates a problem where you could have entire blocks of non-finished transaction out. That's kind of weird, but what I mean by that is you can have like an entire block of like, oh, this was transact, and like when you get to the end of the block data, like there's no, like you'd have to go to another block to get the rest of the information of this transaction or sets of transactions to be able to prove someone does or doesn't have funds. And it can't really be proven because it's not all there. And in this case that I'm describing, I'm not saying it's possible on this blockchain. I actually think they went through and did some stuff to ensure you can't do that exact attack, which was done on, I believe the exact attack was done on Ethereum. But more importantly, it was done on, I think, Solana on accident, like someone accidentally figured out how to do it or something. I don't know. The original person who taught us the sub-second concreting technique, and it was completely by accident, I think. So keep that in mind. It was a complete accident to get malformed code pushed into a blockchain, which resulted in someone being able to transact funds they didn't have. And that's important. It's not only they didn't have, it didn't really exist. And in that case, meaning like you had a UTXO that should have been used, but wasn't used. And so you're just using that UTXO again, but it's not the exact same UTXO, but it fits the build just enough to be approved by the validator. You just got to get a validator whose config file isn't as nice as everybody else's. And so if you have a decentralized node process, they can configure their config files any way they want. Meaning you could have an entire malicious attack team of people with config files designed to allow slightly malformed for ZK snark reasons hashes. So we start coming into holes in the base system. So business model here is building and maintaining the core SUI blockchain protocol. Completely different wording now. So not the platform, not the blockchain, but the protocol for the blockchain. Well, that's Mr. Lab's business model. Building and maintaining this core SUI blockchain protocol. That's how they're controlling you. Boom, right there. By the protocol. It says it's in their business model, supposedly. Their enterprise solutions is providing blockchain infrastructure solutions for business and developers. Half of that's already been done through their documentation. As long as they keep that up, that's maintaining that. The other half, I'll show you how that is. And it is actually kind of neat. And I'll explain why. Because I know normally these are an open shut case, but SUI blockchain is not an open shut case. It's very confusing. But again, I'll give you my full whatever at the end. Want to go to here. This kind of just backs up some of the claims that we read earlier in that that fluff piece over here. This one. So I just wanted to give you guys like another validating point of 2 billion valuation, 300 million raised. We saw publicly, we could see they had a little over 400 million through fundraising funds or whatever. So this is one specific seed freight fund. And if you see FTX is involved, and if we go to the next slide, basically, let's call it that, we can see FTX was one of the big pushers for them. It helped them really go fast. It said bankrupt cryptocurrency exchange FTX said on Thursday it would sell its stake in Web3 focused startup Mystic Labs for $95 million as it strives to pay back its customers. The exchange had nearly 101 million last year for preferred shares of Mystic Labs. So whoever got those, preferred shares. Gosh, that means it's one of the bigger, but there was more room there to take. So 95 million of those caught it quite a bit. And we see now Mystic Labs valued at over 2 billion after the FTX led funding round. So this, them selling shares, turned into a $300 million fundraiser seed. What? Like, it doesn't make a whole lot of sense. It seems very confusing. And I want to say this is actually, this says 2 years ago. Also, 2 years ago. This tells me the initial date. This only tells me the last time it was updated. Not when it was written. The illustration is from November 10th, 2022. Has nothing to do with any of this. So, which one came first? Wait, do they have date codes in the thingy? 2023, 0323. Yep, that was when it was last updated. Only they put the updated code, date code in the link. But not only the original if it wasn't updated. So keep in mind, both of these are from Reuters. So it's basically more the BS, same BS. So there's a good chance that both of those are just fluff pieces, paid for, and because it's by Reuters, and it was in the right timeline 2 years ago. So here we go. This is Mystic Labs blog. This is their blog. Basically explain the Sui Koisk. Sorry, dyslexia. I was about to say Kubi Suesk. That did not make any sense. Alright, so the Sui Koisk. So I think this is probably the biggest selling point of Sui right here. And I know many of you were not a part of the crypto scene at the time the ETH flopped out into the air. But it was the internet computer, and ETH PAL, or proof of work, did have a fun mechanic that would allow for a data block that could hold pretty much anything as long as it was within the correct scripting language. And there was even some college kids that they had built a version of Ethereum network in their college dorms to help each other be able to perform big math problems, because sure, they had access to a supercomputer on site or whatever, but it's like you'd put stuff in, it would take forever to get returned back. And this allowed them to have their own methodology of basically having a supercomputer through an ETH network. Now, it wasn't connected to the mainnet ETH network. This would have been considered a test net, but it showed the ability that ETH was initially designed to be box plug and play swappable with different parts to be able to be the online digital computer. And so, like I was saying, which some of the ETH computer was going with the processor, the backbone of all systems. This SUI is offering the decentralized backbone for your blockchain-based businesses, and this is how they're doing it. It's not very decentralized though when you look at it this way, because if all of our decentralized businesses are being solution partnered directly with Mystic Labs SUI Koisk, that's centralized. It's not decentralized. So Simple Tech is being used to do things that a company is needed to handle. Normally, companies would handle all that stuff, basically being a Koisk. And again, that's not very decentralized. And this does definitely help create more centralized, various interactive stuff like NFT games and interactive NFTs more capable. I want to point that out. This does allow for various interactive stuff like NFT games, interactive NFTs, and NFTs you don't actually own. Centralized, various interactive stuff. So That could be cool. I know there's a lot of people out there that want stuff like that, though. So, okay. So, like many newer blockchains, you have to weigh out the good and the bad. This one has a mix of, oh, sweet, really like that, and ew, gross. No. You got to take your pick on what you like. So, if we're looking at this core system, it's very similar to BTC Pay server. Not the same, but it's very similar. So, Miston has found a way to put every major part of the blockchain ecosystem into a single entity controlled mechanism. One thing ETH had going before ETH2 was simply nothing was bound to a set method to do. For example, there was like now there are three major ways to do marketplaces on ETH. But at one point in time, there was like a dozen ways to do ETH marketplaces. And when I say working differently, I do mean that they were using different ways to solve the same problem to both all have NFT marketplaces. Mr. Labs says this is how Mr. Labs says this is how it's done because it's native to the chain. And that's kind of my point. That's not like a direct quote. That's a generic explanation because they've built every part of the ecosystem under the same belt. They're like, this is how you do it. We already saw that in their integration page. They had an integration for just about everything all into their blockchain. It's not much of it, sounding more and more like a platform to me. Okay. Let me get back on. So in reality, it's just pre-built by the company. So when they say it's native to the chain, they really meaning we pre-built it for you, bro. And that is kind of the trend with SUI in almost all proof of stake chains now. They're all centralized through the foundation or starting company or controlling code entity. Not even Bitcoin goes off the repo. The repo changes based on the activity seen on chain. Sure, there are people actually running the Bitcoin, and they are the miners. And there are also people running the Bitcoin GitHub, and they sometimes put stuff in there that then never makes its way onto Bitcoin because the miners didn't want it. And then they slowly move it off of the GitHub, put it back into the point of, oh, this is deleted stuff. So if you are a person that prefers standards over innovation, and I mean like anybody being able to innovate, you'd rather have just a set standard to do things. SUI is all of that wrapped into one controlling entity. So at this point, I should say I did not explicitly check to see if someone could enterprise their own solution to compete with the pre-built solution built into the native stuff with SUI. So you may need to build everything up, including the wallet or the integration, which that's normal on chains like Bitcoin and Dogecoin. And I do mean it's normal that a new something would have to build up all the structures behind it, especially on chains like Dogecoin that doesn't only have anything for it. But you would directly be competing in this case with the foundation, starting the system and platform and chain that you're working with by doing so. So if anything, you may be able to compete with the foundation, but that sounds like a dumb ideal even from my perspective, which is why I have this is very monopolized already, but it falls directly in line with both proof of stake nowadays and Ethereum and their foundation moves. He's pointing out more ways it's almost exactly like Ethereum now. I mean Ethereum of now. So before we go any further, I need you to know what a novel attack really means. And to be blunt, in this case, we are going to hear about SUI. It's potentially all of the cases where it's a sophisticated attack. I don't normally talk about simple attacks, by the way, and over a simple but innovative strat to a possible 0-day and perhaps an unfixable feature. One that is seen in almost all instant or to near instant proof of anything that has time reliant within their blockchain. That's a lot of words to say. Now we gotta read the first two paragraphs. A novel attack refers to a newly discovered or previously unknown method, threat, actors used to exploit vulnerabilities in computer systems or networks. These attacks have yet to be encountered or documented before, making them difficult to detect and defend against using traditional security measures. Novel attacks often rely on sophisticated techniques, innovative strategies, and zero-day vulnerabilities, which are unknown to the software vendor or that they even need to be patched. Due to their unique nature, novel attacks do not match any known attack signatures and bypass traditional security defenses. Their novelty also means that security experts and software vendors may have to anticipate or prepare for them, delaying development of effective countermeasures or security updates. Detecting novel attacks require advanced security measures, such as anomaly detection systems and machine learning algorithms, which I'll disagree with that end, which many can analyze network traffic and behavioral patterns, which, yeah, MLA can do that part, to identify suspicious or malicious activity that deviates from normal behaviors. Now, the reason why they're saying deviates from normal behaviors is going to be a very important part of what I'm talking, because what I'm talking about is a novel attack, but it doesn't deviate from normal behaviors. It will deviate what is considered normal behavior on chain. So, let's get into an actual representable thing I can show you that you can learn more about on your own later to have a better understanding of the actual attack that can be done on Sui. The hamster wheel. So, I've already pointed out Mist Labs is a controlling party factor. And I keep saying it like that. Controlling party factor means they're a factor to Sui in the form of a controlling party. So just like ETH Foundation is a controlling factor to ETH. When we look into the hamster wheel attack, we see that Mist Labs was directly involved in paying the bounty and handling the issue. The problem was discovered over a lone team, Cerdix Skyfall, and was directly sent to Mistin to get fixed. The problem isn't it wasn't really fixed. It was only mitigated because it's not a bug, it's a feature, in my opinion. Again, in my opinion, it's a feature, not a bug, problem they found. Now, they specifically point in here, in move-based blockchains, Sui and Aptos, the safeguarding mechanism against malicious payloads rests heavily on static verification techniques. These techniques inspect user-submitted payloads before a contract is either published or upgraded onto the chain, with checks ensuring both structural and semantic correctness. Move runtime presumes their soundness. And you can see here, they are literally adding malicious payload into proper, a proper payload. They're doing what too? Sui implements a memory model that is distinct from the original Move design, deploying a customized version of Move VM for contract development. Sui goes the extra mile in strengthening its safety measures against malformed payloads. Introduces additional customized verifiers dubbed the Sui verifiers. These specialized verifiers cater to Sui's unique features such as object safety and global storage access safety, among other things. And they give us a list of things, and they're going to point out exactly what they took advantage of. The ID leak verifier. Okay. It goes to a sequence of checks. It does a struct key, with key verifier, a global storage access verifier, ID leak verifier, private generic verifier, entry point verifier, one-time witness verifier. From everything I read, if you can get past the ID leak verifier, you're pretty much set. Pretty much set. Because that right there, from that point to that point, all those first three checks, that really is like 99% of all the checks you really need to get past. Everything else has more to do with inside stuff and other things that you really have no real control over, but you can, they seem to be less important than those first three. Let's put it that way. Last three are less important than the first three. And I think that's why the first three are the first three. They are really the most important. I think the last three are more for just making sure it looks right and doing a form of hash to get a verifying witness. So those verifiers construct structural assignments against the compiled module. The runtime represents a of user-provided contract payloads. For instance, duplication checker ensures no duplicate entries, while limit checks confirms the upper bounds of entries allowed in each section. However, the more complex analysis is necessary for static checking to be guaranteed the soundness of the untrusted payloads. Beginning in its operation, the abstract interpreter constructs control flow graphs and from compiled modules. Each basic block within these securities maintain a set of states, namely pre-state or post. The pre-state offers a snapshot of the program prior to the execution of the basic block, while the post-state provides an image of the program after the basic block's execution. When the abstract interpreter encounters no back edge or no loop in the control flow graph, it follows a simple linear execution. Each basic block is analyzed in sequence, with the pre-state and post-state calculated based on the semantics of each instruction within a block. The result is an accurate snapshot of the program state in each point of the execution, which aids in the verification of the program's safety properties. In case you don't know what that really means is, if there's no loop detected, it just goes A to B to C to D. Like, there's no problems. It goes as expected. However, when loops are present in the control flow, the process becomes more complex. Back edges, which signal presence of loops, require the abstract interpreter to carefully manage the merging of states. This is due to the interdependence between the state and the start of the loop, the pre-state, and the state of the end of the loop, the post-state. Okay. In handling back edges, the abstract interpreter essentially merges the pre-state of the target basic block to the post-state of the current basic block and does the deficiencies in the text the resulting merged state. The abstract interpreter initially reanalyzes the beginning of the target basic block with the updated merged state. And this initiative analysis process continues until the loop pre-state stabilizes. In other words, the process is repeated until the pre-state of the loop header no longer changes between iterations, indicating that a fixed point has been reached and the analysis of the loop is complete. Pretty smart. Has problems with it, but it's pretty damn smart. The ID leak verifier, alternatively known as the ID leak verifier, operates in concert with the abstract interpreter to conduct its analysis. So, in form of the distinct abstract domain termed the abstract state to oversee the status of each local verifiable using an abstract value, this value denotes whether the ID is fresh. During the process of struct packing, the ID verifier checks that only a fresh ID is allowed to be packed into a structure. It meticulously traces the data flow of the local states to ensure that no existing ID is transferred to other objects. I got one more to read. No, a couple more. Okay. In abstract state join, the function takes another abstract state as input and attempts to merge its local state with the current object local state for each local variable in the incoming state. It compares the variable value to its current value in the local state with the default value of the abstract value other if it's not found. So it uses an abstract value other if it's not found. If the two values are unequal, it sets a change flag and updates the local variable's value in the local state by calling abstract value join. In abstract value join, the function compares its value with another abstract value, and if they are equal, it returns the incoming value. If not, it returns abstract value other. Reset one, basically. However, the conjunction of these functions can lead to a potential inconsistency. Although abstract state join may indicate a change due to differing old and new values, the state value after the update might remain the same. This normally occurs due to the order of operations. The determination of change status happens before. So abstract state join happens before abstract value join, which doesn't reflect the genuinely updated state value. Besides an abstract value join, abstract value other dominates the join result. Thus, if the old value is other and the new value is fresh, the updated state value remains changed in other or as other. Here's your problem. get it to loop back to itself, and still be new, and you can kind of bypass this entire check. This introduces an inconsistency where the basic block state is marked as changed, but the state value itself remains unchanged. Such inconsistency can potentially have significant implications to understand why it's crucial to recall the abstract interpreter's behavior in the presence of a loop within the control graph. When encountering a loop, the abstract interpreter employs an interactive approach to merge the target to the current state. If the joined state changes as a result of this merge, the interpreter triggers a reanalysis. So what we're saying is we can get it to stop reanalyzing. We can get to a point where it either won't ever stop analyzing, or we could potentially get to a point where it just doesn't reanalyze when it should. So according to the bug bounty conditions set by SUI, the vulnerability to reach level of critical severity, it must exhibit a capacity to bring the entire network to a halt. I think that's kind of important. So they consider any other non-complete network halt as a critical severity. And one of the things I'm going to point out today is a way to do basically this without halting the entire chain. Or you could. You don't have to, though. Implementing new transaction confirmations and requiring hard fork or resolution. So that other last bit is kind of cool. If you can get it to hard fork resolutions, or get it to prevent or not allow new transaction confirmations. Lesser impacts, such as partial denial of service, can be best qualified as medium or high severity based on premise of the bug program. So what I'm saying, they're going to consider what I'm talking about probably as medium security, basically what I'm talking about. But let's keep going for this one, because this is going to explain really what we're going to get into. So enhanced real tech discovered by Skyfall team carries an immersive threat due to its potential to shut down the entire network. The impact that earns its classification as severity. To understand that this gravity is the flaw, it's necessary to comprehend the intricate architecture of SUI's backend system, especially the steps leading up to the publishing, upgrading, and transaction on-chain. They give you this point. And the only thing they were really messing with is the certification process. Everything after the certification process is pretty much done. Be right there. No, I'm sorry, you can't see, my head's in the way. After certification, you're done. That's the only part you need to mess up. And that's all Hamster Wheel does. Mess that up. So in response to this discovered vulnerability, SUI confirmed the vulnerability in a timely manner and releases a fix to address the critical flaw. The fix ensures consistency between the state change and the changed flag, limiting the critical impact caused. I disagree that it eliminates the critical flaw. I'm sorry, I said that wrong. I agree, it eliminates the critical flaw. I disagree that it eliminates the flaw. In order to eliminate the inconsistency, SUI fix consisted of a minor but crucial adjustment to state join function. Instead of determining the change prior to join, it does the join first. And I'm going to point out that now that it's doing join first, the reason why they probably didn't do join first is because, well, you can, if you check it and it is malformed, you might need the previous state to check with other. So that's exactly what you need. So now that we're joining it first, if we can loop back to ourselves, we can bypass this entire process in one simple loop, because it will think that the next loop doesn't change anything, even though it does. And how do you do that? You have it loop back to itself. You have your program loop back to itself. You have your program loop back to itself. You have your program loop back to yourself, but eventually it ends. Dead serious. When I say, I make it sound easier than it really is. Do not like make me think that sounds as easy as I make it sound. I'm trying to make it understandable for you to understand as easy state as possible. This bit in red does mean that there is now a way to potentially force pushes when we have fresh data or old data that is malformed only enough to be fresh with potential data inside. They do use zeroth proofs, so there is always going to be a vulnerability to possibly to There's always going to be a vulnerable to possibly empty data sends or inbound blank data bloated proofs, which is just a fancy way of saying because they are hashes in the system that contain no technical data, the system will always have a way to allow empty data or malformed read data to be empty for a fresh data structure within a real system, which could either be another consistent stopping issue. And this exact issue is in all ZK-proof systems and in almost all POS stacks. And believe it or not, this exact issue is why Bitcoin does not use zero proofs, because no one's stopping anybody from using zero proofs on Bitcoin. That initial testing was done in 2016, 2015, and I think 2017. And out of all the times it happened, using zero knowledge proofs created multiple problems like lost data. So I'm going to go back to the purple. In addition to fixing the specific vulnerabilities, Sue also employed mitigations to reduce the impact of further verifier vulnerabilities. So I think what that really points out is that they noticed that the whole verifier is an actual vulnerability. But they're not going to admit that. But they do admit something. According to Sui's reply bug report, the mitigation is involved in a feature called denialist, which we've seen in other blockchains, and it's being abused. We're going to explain how to abuse this exact thing again. One of the things I want to point out, the denialist enables validators to temporarily circumvent the verifier routine by disabling the publishing or upgrading process, effectively preventing some potential disrupts from the problematic transactions. It's basically like you hear your own noise instead of hearing everybody else's noise. Alright? And what I want to explain later is how to set up an attack to get other people to stop listening, to auto turn on their deny list, or to put you on their deny list, or like we're gonna take real people and they're gonna do things unknowingly that's going to bypass this entire mitigation system using the deny list system by getting real validators to just stop listening to everybody slowly. Because one of the key points to an attack is it has to be different than native activity. But at this point, it will be native activity and normal behavior on chain. Therefore, it is not an attack. Now, here's the whole point of how they handled everything, the commit number, which allows you to now search within all of Sui's back data. Believe it or not, there's all sorts of like videos on Google Google and YouTube and whatever that tell you how to use this one date code now, how to use this one bit of comment code to actually search the entire backlog. Anything that's been deleted or anything like that. So if they have anything hidden in there, you can just take that and run with it. Have fun. I'm not going to actually show you how to do any of that. It's up to you to do if you choose to. So they basically say, yeah, this was bad. It just basically says, look, they kind of fixed it. They mitigated it some more. But this fix is a common way to fix things, which is just ignore temporarily. However, this isn't as bad as how Nano handles this problem, which is ignore forever instead of temporarily, which I've claimed in the past is an attack on users. Ignoring can be used as an attack, and if it has a forever implication, it can definitely be used as an attack on users. And because this is a pay-to-enter system by default, that could be... There are people that could sue for their money back to the developers or the foundation specifically. However, this fix introduces the same nano bug, the smallest spire attack, or SBA, and better than like the considered normal proof of stake attack, which is normally buying off trusted nodes like the validators. SBA only worries about the little guys. That is normally more the line of the system that can repopulate very quickly, like a proof of stake DDoS. And I do mean that literally. SBAs are proof of stake DDoS in any way, shape, or form. So let me explain something. In an SBA, I want to get rid of this thing right behind me so you guys don't So an SBA is where the smallest players are paid to perform actions at extremely low rates, normally incentivizing increased rate of node users performing these actions. So we are not buying off node operators like most proof of stake chains protect against with delegates and paid entry. We're not even doing that. We're just paying them to do things. These actions are not attacks being purchased, but are allowed actions by the network. And I will point out now that one of the actions that people will be paid to do in this attack is to ensure the proper validators are validating to keep this payment method going for the lowest based users on this network. And all the new ones. And all the new ones after that. And all the new ones after that. As long as they make enough money to create another account and have a little bit extra, they will keep doing this. So the actions are not attacks being purchased, but are allowed actions by the network. Unfortunately, by doing this, the actions in mass, they cause natural chaos in the proof of stake consensus. And any network reliant on timing mechanisms that are based on in real life time instead of in real life actions that prevents moving forward in chain time, or network time as it's previously known as. So what actions are we talking? These actions range from ignoring, changing who can handle your actions for you, staking, unstaking, simply doing normal activities like buying NFTs, trading, selling, those things, every minute or block, or just any on-chain action really as often as you can. The smallest players are more susceptible to taking a different currency at smaller rates and values if it can be swapped easily or exchanged at the time of accepting the job. Only a handful of bigger names need to do a video or talk about this setup as a passive payment system to basically help it go viral. And just seeing the on-chain payment one time would be the biggest push ever because it's a permanent proof of payment. And even a long relative period of time, so to speak, after the payout tokens are unusable. Is it going to take months? Well, people are going to have to buy it and realize they can't sell it to get proof of that and get that out there. It's actually harder to get that proof out there than it would be just to get on-chain proof, because on-chain proof is a simple click away. Traditionally, this attack is done with both on-chain currency and off-chain currency, causing a disruption on-chain for that token. So you'd give them a little bit of the SU, whatever's backing that SU blockchain, as well as, or any derivative coin, plus off-chain currency that is normally swapped for SU, for SUI. And so off-chain currency causing disruption for the on-chain token and exchanging that on-chain token. In this case, people then try to offload their earned tokens from these actions. Slowly, the exchanges are low in liquidity because of everyone offloading these earned tokens. And with the chain and not buying these tokens anymore, basically, this is a dumping mechanism on a token to pay out others to completely halt the chain, or even potentially partially halt the chain enough to get enough people mad to cause lawsuits. Sure, some will get paid at first, but others will just sit in limbo nearly forever, in some cases, waiting for liquidity to arrive. Meaning you can actually load up very little liquidity on an already dead coin, and bingo bongo, you have a nearly free payment method. Just pre-buy your tokens in small batches before doing this attack and prevent uprise in the token value, and it will look more like natural demand slowly happening over time. So when you have a boom of relative buys and such or use, it's believable at first. Imagine a chain that is ignoring everyone simply because almost everyone is just overacting within the limits of the chain. But because there's so much traffic, people are auto-ignoring getting activated. So they're building up these like back data things that we're going to take advantage of to stuff with stuff that shouldn't be there. But it's all going to be fresh and meet the regards for the future checks. And these are normally things that keep stuff safe, but we're going to abuse it. Because if there's enough auto-ignore being done, it gets activated on enough node runners changing their settings if they can. Some chains use on-chain changes to keep networks safe. But that also means that if the majority is ignoring and you need another on-chain chain to change that, you may not be heard to change your settings after that. One thing that makes this type of attack so brutal is if actions are almost instant or near instant, you can't actually prevent the situation for as long as there's only one way to verify IDs without chain scrubbing. SUI uses local scrubbing and network checks, but not network scrubbing, because the way DAGs and many proof-of-stake chains work is, well, the data may not be verifiable by the network scrubbing. That means it might be some unknown amount of time later before you could scrub the network to actually find the data you're looking for, because DAGs are not always in line to the same point. That's the beauty of a DAG. You can have them work in clusters instead of all working as one giant group, like Bitcoin does. So they can't rely on network scrubbing pretty much at all. And we saw earlier how SUI has a one way to go from user to chain via the authority aggregator. So if we can malform data during these noisy chain times where we're not getting anywhere, we could actually add in bad or fake data, and when it goes through the regular checks later, it will verify, because you got enough verifiable data to verify, and not enough data. You have enough loose data there to basically say, well, maybe the stuff isn't available yet. There may be another bleeding edge to look at that isn't there yet, so it can't change, and it might not ever be there ever, so it will never change in the next check and bypass that check completely. Yeah. So they already have a very smart part of this attack on chain, and another part of the attack was discovered to exist on SUI before the mainnet launch. But unfortunately, this is not stoppable from the design of the chain. Fortunately, though, this type of attack would take much time, like minutes of actual skilled programmer, to get a script ready or script call ready to perform just once, and then after that it's done. Like we saw with flash loans, there was a programmer who spent like 6 months or so to get the flash loan script working, and once it was done, we saw it on chain, and it was repeatable instantly by other people who didn't even understand the code. They just knew where to replace with equivalent objects that directs to their wallet. And what I'm really saying there is they were just going and changing the wallet address for the payment. That's all they were. They just gotta, okay, who's paying and receiving? One wallet address. They just gotta change that wallet address. Okay, we're gonna go back into the thing. Whoop. Here we are. All right, so the attack, it's a little bit SBA attacks for SBAs are always sophisticated sounding, but there is this video here on Odyssey, which is an ASMR rant of specifically me, why I don't like Nano, and I just basically explain how an SBA is done in the simplest and cheapest way on any proof of stake designed system. So it's a non-technical generic explanation of the basis of SBAs. And yes, it is being bitchin', but that's also the point. People right now are participating in attacks like this and are completely unaware of it. They think they are buying the next best NFT or token, but are actually being used by marketing to get you to DDoS or partially DDoS the chain. The only part of this attack that isn't really needed, like it can be done in tons of ways other than this. But I did describe using lost liquidity attacks to pay people in here as well. So it's the similar payment method setup. That's where tons of large amounts are distributed of these tokens, and when people try to sell off large amounts, the liquidity rapidly disappears or falls. And the liquidity is, wouldn't it be when it's based off of value difference, like so one token versus the other token, not the number of, but the actual value difference of them comparably to each other, which is basically how almost all exchanges work, really. You get to a point where you can go from bloated token to falling token, but you'll never be able to get out of the falling token. And it's a very common meme coin issue, especially on proof-of-stake chains already. And keep in mind, this was in 2020 when I did this, and at the time that no one had ever seen anything like this. And since then, there has been, like, I think 5 different Solana downs that they claimed was something similar to this. They didn't know what it was called because they don't know this video or me, and they only briefly described that people buying tokens and trying to offload them very quickly in a script-like manner, like flash loans almost, that it was causing inability to verify, and then preventing some validators to actually be validators and validating. It basically stopped validators partially. And partial validator stopping is not chain halting. So other people are getting through, other people don't notice anything, and then bad actors are on the other side of the networks, so to speak, performing actions of checks that can't actually be checked, so they're verifying. And in case the chains that we saw in the past, like Solana and stuff, they actually do their verifying checks slightly different, so it's not the same as ones we read for Sui earlier. That in mind, but I still say, in part, it is on-chain issue, the DAG issue. Now, this entire research paper will explain why greedy algos and non-linear structure causes loopholes in their internal verification system, and in short, Stewie is hoping to make this loophole more difficult to do by blocking the easiest way to perform this trick, which is proof dupes, or duplicating good proofs. However, that's only one form of this attack and that's the only form of this attack it's protecting against. SPAs lie within the range of incentivized attack on a blockchain, but with random chain actions instead of exploiting random transaction selection or without buying validators. So this is also why DAGs tend to rely on proof-of-stake style technologies, so they can be decentralized within a controllable state, even if the central entity is not there or exits without failure to the system. And a good point to point out here, to be completely honest, in my opinion, the reason for this nowadays as being more possible isn't a failure because they left. The technology is just super dynamic and designed to work. It will work regardless of who is there now. It really matters who put it in. And so for the longest time, when technical people say controlling entity in technology, they really mean that if that entity leaves, the solution they had put in place fails. But nowadays, because of how good technology really is, code and technology doesn't have to be reliant on the company after it's initiated. It only needs to rely on that company to be initiated. And then from that point on, it could forever pave the initiator. So I think everybody in the tech industry should be changing what they call a controlling entity to what I'm about to say right now. If other solutions are competing with the entity that placed its existence or began its existence or is used to keep its existence, then that entity is a controlling entity. It should not be based on if that entity goes away. It doesn't always fucking matter. I can make a system get enough people to participate in it that I can just jet off and disappear, and the system still works, and I still get paid. We have to look at what we call a controlling entity in this new way. If other solutions are competing with the entity that placed its existence and or began its existence and or is used to keep its existence, then that entity is a controlling entity, even if all three of those are different and all the same entities, or even a mixed combination of. Doesn't matter. So that is my opinion, but my opinion based on the reality of many blockchain technologies already out there, and we've went over one specifically that I still say it's completely controlled, and that is XRP. And I've gone over how I believe it's controlled, even though it's very decentralized. It's still controllable in one way, through one point in the consensus. These people have controllability through building the entire backbone of anything you want to do outside of consensus. That's creepy. Oh, says read methodology, and they do show a lot of stuff and blah blah blah. It says read methodology. Page 11. Oh, I'm not want to go over all of this. You guys can always come back and come look and see thing right there. Methodology and results. So the methodology you see was used setup to 5 and 0.05 seconds. 5 seconds to 0.50 second, 5 seconds, effectively 5 seconds to 5 seconds. When comparing these two settings, one can expect see significant. I think I missed. So a single miner is always more profitable than multiple miners, which is no, that's not the part we want to get to. I think it's lower. Ah, yes. Goal. The goal of this experiment was to investigate the effect of different network topologies on the impact of incentive attacks to DAG protocol. And we experimented with 3 distinct network topologies, and shown in Figure 10, which you guys can go look at that later. And each topology experienced unique characteristics which might not be realistic, but enable us to investigate the effect of the incentive attacks. The line topology represented in the worst case scenario where the gossip between 2 nodes were the slowest due to the presence of the only path for block propagation. The one that was the worst is the one when they only had one path for block propagation. There was only one path for block propagation in this setup. The common topology represents the most realistic scenario with a strongly connected core and weakly connected edge. Welcome to this entire ideal of DAG. And they show you how they implement randomness and all this other stuff, and it comes down to, problem. It's easier to incentivize attacks on DAGs than most other networks for reasons that are included to there's one way out, one way to confirm. And I'm going to go back to this so we can show you exactly what I'm talking about. There's one way out, there's one way to confirm. Here's that. I think it's on the next. I'm looking for it. Hold on a second. Hold on. I don't want you to go away. I want to show you where it's at. I know it's in here somewhere. We were looking at earlier, like a left to right thing, and clearly, visibly showed the issue. Ah, there it is. On their GitHub. That's right. It says, in all 3 topologies, the ones that were the slowest, the ones that were the worst, were the ones that only had one way to get to chain. There's only one way to get to chain, and that's authority aggregator. And we already know that the authority aggregator can basically handle get load offline, non-chain comments, non-chain data, and when we're actually performing that, it is a collection of the sum that is actually going through. It might do individuals, but it also does a collection of the sum. And when we do a collection of the sum, we can actually bypass the entire thing, which should be first. So, here is an entire research paper on novel attacks on blockchains in relation to their layer formation. I'm not going to go over this entire paper. I wanted to give you this in case any of this sounds kind of cool to you or neat or just different you want to learn. It is actually really cool, but I am going to go over a small little step in here, which we had on screen. I just basically want to go over some of these novel attacks. These were like first-time attacks ever seen. Bitcoin's transaction mutability vulnerability was exploited to orchestrate an attack on the renowned Mt. Gox exchange platform. This exploit community, we've seen transaction mutability vulnerabilities in other blockchains after 2014, even though it was discovered to happen in 2014 on Bitcoin. In June 2016, a malevolent actors directed their attention to the reward of the Decentralized Anonymous Organization, or DAO, ONIs, a smart contract entity. These attackers capitalized on a vulnerability arising from recursion calls within the smart contract, leading to a misappropriation of approximately $16 million. I believe in that case they were actually able to recall calls with different to and from points, so they were actually able to just like basically see a call, recall it, but with their output address and get money. And I know that's like generically saying what it did, but that's a very generic way to say it. That's also one of the main key points that we're talking about. We're talking about doing recursion calls to the mutability of the transactions instead of the V8 enough, possibly real data, to go as real data. So hackers compromised the encryption. Oh my bad. In December 2021, hackers compromised the encryption of 2 hot wallets linked to Bitmark crypto exchange. Due to the hacked private keys, the hackers were able to steal assets up to $150 million. In May 2022, Terraform, a decentralized finance service, experienced a cryptocurrency bank run through a vulnerability in its protocol, where the hackers took advantage of Terra, the third longest cryptocurrency ecosystem, soon lost $50 billion in evaluation. In November 2022, FTX, the then third largest cryptocurrency exchange platform, went bankrupt, leading to a loss of $9 billion. This happened partially after an article by CoinDesk highlighted the fund's mismanagement issues in the exchange. So I want to point out the very last attack on this was an internal attack, and is considered novel. FTX, the way FTX went down, is considered a novel internal attack on themselves. Terraform is considered a novel attack on the exchange, or the exchange part of that. Terra had this 2 token thing they could exchange back to each other, and it took advantage of that, with native to the chain. Hackers took advantage of hot wallets, not native to chain, in December 2021. Hackers took advantage of native to the programming language of the blockchain to attack in 2016. Attackers took advantage of the fact that you had mutable transactions allowed on a chain in 2014. All of this is technically possible on Sui. And I say technically, meaning I didn't actually sit down and figure out a methodology for each and every one of these situations. I just want to point out that each and every one of these situations should be possible to do on Sui in some form right now, at the time of this air. And I do really want to point out something super major before we go any further. Today is not a full day of proofs like I normally do. I have a lot of proofs, but the things that I'm actually proving are not directly what I'm saying, right? They're related, correlated, or similar. And that's not because it's hard to find these proofs, but because only a handful of people have even tried the things I'm talking about today. To be honest, with these ending points I'm leaving you on, will hopefully spark your curiosity to get you to want to try something, like look into Sui or try Sui or whatever. I'm not saying Sui is broken and everybody should run. But what I am saying is the following. And again, this is completely my opinion. Sui is being set up in the same pyramid scheme way ETH was set up, and many of their competitors are set up in this today, which is, in my view, basically legal money laundering. Because they are not mineable tokens, and they are mechanics that can fight the users of the network, like the ignore state and similar mechanics that we talked about earlier. So if any user fights against the controller, you may be ignored. Sui has a major cloud backer, including AWS, whom was the major cloud provider partnership with ETH that ETH got with after the ETH Classic debacle. The similarities between Sui and ETH are absolutely uncanny and very creepy, like a playbook of sorts. Sui is a DAG with proof-of-stake mechanics and has all of the proof-of-stake issues and all the DAG issues, which many of these issues are still, again, unproven and or potentially unfixable because they are features, not bugs. Sui is owned by very big players that want to make a profit. Sui is ran by top peoples in their field that want to make a profit. Sui is set up to survive for as long as their foundation exists. I'm not saying that they'll die if the foundation goes away. I'm just saying for as long as that foundation exists, Sui is set up to survive. And just like all other proof-of-stake That's a comment. That's actually pretty much the way to go. Almost all proof of stake chains, if that has a foundation, that chain is pretty much set to survive for as long as that foundation exists. Doesn't mean it won't survive after or will survive after. It has nothing to do if the foundation goes away today. I'm not saying Sui can't survive without the foundation. I want you to be aware that Solana, like many others that have foundations, I mean, just because it's a DAG doesn't mean you have. Just because it's a DAG doesn't mean you lose the problems of proof of stake. But because it's a DAG, doesn't mean you have to have network-wide drops of service. Or even just drops of seemingly times of unusability. And I don't mean relative unusability, but where not just people, but everyone is waiting for, and no one is getting through. That type of unusability. So the main difference between Sui and other chains is marketing. Then the foundation behind Sui has built the systems that made other peoples in the past insane amounts of money, like OpenSea. So don't expect similar types of big business players on chain because Sui has already cut the need to compete with the foundation on chain. You pretty much need to use what's built. I'm not saying you have to, but you pretty much need to. And by this I mean just like all proof of stake chains, unless you become a validator, nothing you build has to work. While on standard proof of work chains, if you can talk to the chain, just sending to it, you can build on that chain. Sui has validators. That is a proof of stake consensus mechanism or mechanic. And not all Sui people can become validators. Keep that in mind. I'm not saying Sui won't work, but validators decide whom gets blocked and whom doesn't. So if a malicious validator is able to stay in validation because people are trusting them and they got money staked and they keep staking more, all these different things, there's no reason why that can't survive within that network, even if it kills the network partially or completely. Okay, so at the end of the day, proof of stake mechanics are always for profit. And normally for the foundation or controlling factors. And the reason why I say that is because with proof of work chains, the miners are the controlling factors, whom is ran by the choice of the user. Nodes are verifying and communication factors only with proof of work chains. The proof of stake mechanics, the foundation and the validators of the systems the users use on chain are the controlling factors, which is normally a minority of the users participating in the foundation or as validators. And in case you're misunderstanding what I'm meaning, I'm saying with proof of stake mechanics, foundations and validators are the controlling factors. They are the minority of the participating users normally, and then at the same time, users are normally the minority in participating in the foundation or as validators. Based on past proof of work or proof of stake chains, the users are relatively rarely validators and almost never foundation members. So at this point, you have to make your own opinion about Sui or Sui. Mine is pretty much set. It's for profit, just like the rest. They'll fail in the same or similar ways as their competitors, but Sui has more money than most of their competitors, except for maybe ETH and XRP. So it'll be around until some other bigger or newer entity drops them, like is better than them, drops them out, or plays them in court. And I know that sounds bad, and I don't mean it like, oh, they're going to get sued. I mean, they're going to sit there until they get played in court. We saw XRP go to court and not get played. And now they have a brand new competitor that people don't even realize is competing against them. But at the same time, maybe XRP owners knew it. I don't know. All I know is the more you look into Sui, the more you realize, just like another ETH, just like another proof of stake NFT pusher, the only difference is everything's pre-made. Everything's pre-built. You can plug in, access, jump in, go in. You can build a system that works right alongside what they already have made. You don't have to worry about platform-based things because the entire blockchain basically seems to be a platform, and in some cases, in some of these fluff pieces that seem to be potentially paid for, has even said that they're a platform.